Hi everybody, David Peacock here. We're going to look some more at my DVD shelf because that's a great way for me not to actually have to think up a video idea. So this is another DVD shelf, one I didn't show before. This is like my Disney and Pixar films. Here we go. Here's Muppets, Sesame Street, other animated films like Shrek. Here's some more wonderful films. Love the Babe movies. Here's my Marvel Cinematic Universe. Star Wars, dinosaurs, Fraggle Rock, some other shows. Now, you might be wondering, by the way, when you look at my Marvel Cinematic Universe, if you pause, where is Phase 1? It all started with Iron Man 3 there. And the answer is very simple. Phase 1 is in this little, nice little container right there. But you know what? Let's actually, since I mentioned it, use Iron Man 3 for today. Now, you might be wondering, Mr. Peacock, I saw the title of this lesson, and it is Area of a Regular Polygon. How are you going to talk about that with Iron Man 3? I mean, with Iron Man 2, you could have gone, well, he turns his arc reactor into a triangle, and equilateral triangle is a regular polygon. How are you going to do that? Well, here's the thing. With Iron Man 3, directed by Shane Black, the last of them to actually claim Paramount as a company that made it, at the end of this film, he gets that arc reactor taken out of the middle of his body because he wants to be a more regular person, just a regular run-of-the-mill billionaire who still apparently makes Iron Man suits because they kind of throw away the ending of this movie and the rest of the films. But there you go. Iron Man 3 and regular polygons. Today we're talking about how to find the area of a regular polygon, and that's our lesson today in geometry. Alright, so let's start talking about the area of a regular polygon. We're going to find our center with me, David Walker Peacock. So let's get started by just talking about regular polygons in general. So a regular polygon is a polygon whose sides and angles are all congruent. There are two main lines that go through the center of a regular polygon. The first one is one you actually have already heard of. A line that goes from the center of a polygon to the vertex of a polygon is a radius. Now you might know a radius because of the fact that that's what we call the line from the center to the edge of a circle. So this would be the radius of a circumscribed circle to this polygon. Now, if we wanted an inscribed radius, we would actually have a line that goes from the center of the polygon to the midpoint, and we call that the apothem. So we have the radius and the apothem. So now let's talk about this regular polygon and see if we can come up with a formula to find the area of this regular polygon. So the first thing I'm going to do is I'm going to create a second radius right here. All right, so this is one of these triangles, and in the case of this polygon right here, there are 2, 3, 4, 5, 6 polygons. So now let's talk about this with just that first polygon again. So we have one polygon here, and if we wanted to find it, we would go 1/2 of the base times height. But in this case, we wouldn't be saying base times height because that's not the height of the polygon, it's the length of the apothem. So we would say 1/2 apothem times base. But there isn't just one triangle here. There are 6. So we would actually do 1/2 apothem times base times the number of sides. Now, we'll come back to this formula in a second, but let's remind ourselves what something is. So if we wanted to just take this b times n, so the length of the base times the number of sides, well, that would end up being the same length as the length around the whole figure, which we call the perimeter. So let's go back now to our formula. We're going to take away everything else, And to remind you, our final formula would be 1/2 apothem times perimeter. And that is our formula right there. Now, we're going to be doing some math with this throughout this lesson. So let's start with this very first one right here. So this says that we have, in this case, a apothem of 14.4 and a base of 13.9. So let's do a little bit of math with that. So to remind you, our formula is 1/2 apothem times perimeter, so 1/2. The apothem in this case is 14.4, and the perimeter would be times 13.9 times 1, 2, 3, 4, 5, 6, 7 times 7. Now I could go into a calculator and calculate the exact perimeter first, but honestly, I'm just going to say that the perimeter is 13.9 times 0.7. So I go into a calculator and I write 13.9 times, not 0.7, just times 7. And then, well, why did I just do that? That's 97.3, but that's the perimeter. I'm just going to do 1/2 times 14.4 times 13.9 times 7. And that gets us 851.76. And that's the area. So let's try another one. All right, so here we have it. Once again, it's 1/2 the apothem, which is 16.5, times the perimeter, which would be 12 times, let's count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 12 times 9. So 1/2 of 16.5 times 12 times 9. So 0.5 times 16.5 times 12 times 9 gets us 891. Technically, we should be writing units squared. All right, so now let's talk about what happens if we're missing parts. So sometimes you'll be given the side of a polygon or the apothem of a polygon, but not both. Sometimes you'll just be given the radius of a polygon, and you'll have to find it all from there. And we can do any of these, so let's talk about how. So in this case, we are given that the base, or a side, is 5. So the first thing we need to do is find the central angle. So we'll find the missing part, and we'll use trig for that, but first we need to find the central angle. And to do that, I just go, how many sides are there? And I divide 360 by that number. So in this case, I would be saying 360 divided by 5, which would get us 72. Okay, so now I know that that's 72. Let's move on. Now, what we want to do here is we want to divide the central angle by 2 to get the measure of the right triangle formed by the apothem. So in this case, 36 degrees would be that. And so then we want to use tangent to find the missing length, and we put our values into the formula. So let's do that real quick. So tangent, so let's see, I know that this is 5, that means that this part right here would be 2.5, and I need to find x, which is the apothem. So let's see, that's opposite, that's adjacent, so the tangent of 36 is equal to 2.5 over x. That means this ends up being x is equal to 2.5 over the tangent of 36. I'm going to put that into my calculator now. So let's see, 2.5 over the tangent of 36. And I'm just going to double check and make sure that I am in degree mode. I sure am. If I wasn't, I might have gotten a wrong answer. But I end up getting that that is 3.44 approximately. So I write 3.44 approximately, although I'm going to actually use that exact number whenever I put it into my calculator. So now I'm just going to write 0.5 times, I'm going to do times the answer, times in this case 5, times 1, 2, 3, 4, 5. So really times 25, which gets us 43.01. So 43.01. And that's what we end up getting there. Let's keep going. All right, so now we're going to try this one. So this is a, so let's see, this is a 30-60, well, this is a six-figured side, which means each of these angles is 60. If I go like this, I'm going to do this one over here. This is 60, which means, wait, this is 30, which means I actually can do a lot more. I can do this one without even using trig. This will be 4, and this will be 4 square roots of 3, although I am going to just put this in the calculator and let the calculator do it. If I wanted to do this a more accurate way, I could end up doing 8 times 6 divided by 2, which is 24 times 4. But that sounds like that, and I could then say square roots of 3. But instead, I'm going to do 8 times 6 times 4 square roots of 3. And then I'm going to divide all of that by 2 to get 166.27. So this is, to make it clear, 1/2 4 square roots of 3 times 8 times 6. All right. Which, like I said, gets you 166.28 approximately. All right, so here we have another one. We're going to try it. This, we only know that the apothem is 2 feet. So the first thing I need to do is I'm once again going to find that magical, beautiful central angle. So let's see how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8. So first thing I'm going to do is go into a calculator, do 360 divided by 8. That is going to get me, so 360 over 8 equals 45. Okay, I should have known that because 360 divided by 4 is 90. So that means that this angle is 45. But I actually need half of that, meaning I could have just done 360 divided by 16. But that's going to mean that the angle I'm actually looking for in this case is 22.5 degrees. All right, so I know the apothem, which is also the adjacent, and I need the opposite. So I'm going to go, the tangent of 22.5 is equal to x over 2. So in my calculator, I'm just going to write 2 times the tangent of 22.5. And that gets us 2. Tangent 22.5 is, okay, so this part right here. So the opposite is approximately 0.83. I multiply that by 2, and I'm going to actually multiply the real number by 2. That's going to get me approximately 1.66, which is actually the same thing, so it looks like we have a pretty decent. So each side is 1.66, and then I'm going to do 1/2 2 times 1.66 times 8. So 1/2, so I'm going to take this answer times 8 times, well, 2 divided by 2, which means I didn't really need any of that. And that gets me approximately, and I'm actually using the real number here, so you might get a different number, 13.25. You might be getting 13.26 if you actually were rounding each and every step. All right. Now we're going to try yet another one. So in this case, we know the base is 5. I'm once again going to go off on a different angle before I find this one. So to find that, I do 360 divided by 1, 2, 3, 4, 5, 6, 7. So 360 divided by 7, which is going to be, I'm sure, just a wonderful and easy to use number. That's right, 51.428 gross. So this one I am going to have to round throughout. 0.43, I divide that by 2. That's going to get me, all right, so 25.71. See, if I had done it the other way, I would have done 25.72. So 25.71 approximately. All right, so from there, I know this is 2.5. I'm looking for this value. This is adjacent. This is opposite. So the tangent of 25.71 is equal to 2.5 over x. That means that the x and the tangent are going to end up switching places when we do all the math. So we did 2.5 over the tangent of 25.71. I put that into my calculator. So 2.5 divided by the tangent of, and I'm just going to actually put in the answer still. And I get that this value, the apothem, is approximately 5.19. Once again, your answers may vary a tad, in part because I am doing this one way and you are doing it a very different, and you are probably rounding where I am not. Okay, so the answer is approximately 5.91. Then I just do this number times, let's see, 5 times 7, then divide it by 2, and that's going to get us 1/2, 5.19 times 5 times 7, and that is going to get us approximately 90.85. There we go. So now let's talk about finding the area of a circle, because we actually already know this formula, which is what I find very interesting and what I actually want to go into. So we already know that the formula of, well, a circle is pi r squared, but we'll get into that. First, let's look at the shape. I want you to ask yourself what happens as we add more sides. So let's watch. Okay, each time we add more sides, you should notice something about the shape. At least to me. Each time we add another side, the shape begins to look more and more circular. To where if you were to search up like a 100-sided figure or a 1,000-sided figure, it would start to look less and less like we actually were looking at like a polygon, and more like we were looking at a circle that had just been poorly done by a 3D rendering engine. So we already know that the area of a circle is pi r squared. And we actually just learned that the area of a regular polygon is 1/2 of the apothem times the perimeter. The question is, can we use that formula for the area of a regular polygon to find the area of a circle? So let's try it out. Okay. So I'm going to remind us by keeping it up here. Area of circle is pi r squared. Okay, so we have 1/2 apothem times perimeter. Now we've already established in this case that the apothem is really the radius. And we know the perimeter is 2 times pi times the radius. Okay, so let's multiply these out. This ends up becoming 2 over 2 pi and the radius times the radius. Or this part cancels out and the radius times the radius becomes, that's right, pi r squared. So there we go. We have now shown you that the area of a regular polygon actually works all the way until it approaches and even meets the area of a circle. So there we go. And the only thing left for all of you to do, now that you have learned this amazing fact and have your mind blown, is to celebrate how mind-blowing this fact is by liking and subscribing. That's right. Thank you all very much. I hope you have a wonderful day, and I will see you next time on geometry.